Hello everyone, welcome to Risk Roundup. As the smart autonomous future dawns upon us, the security risk for the rapidly growing intrinsic web of connected things across cyberspace, geospace, and space, in short referred to as CGS, is becoming very complex. This is especially a cause of concern because while we are still struggling to manage the security risk from cyberspace, and because of cyberspace in geospace and space, security is becoming even more challenging when quantum computing is well on its way to becoming a reality. As a result, understanding how to secure Internet of Things and its ecosystem is becoming a priority, especially in a post-quantum computer era. So as we move forward in implementing the IoT ecosystem across CGS, it is important that we are prepared for the security of connected communications in a post-quantum computer era. To discuss how to secure Internet of Things in a post-quantum era, I'm delighted to welcome Larry Karisny to Risk Roundup. Larry is a post-quantum encryption, AI, and deep learning advisor, and he's based in United States. Welcome, Larry. We are so very honored to have you on Risk Roundup.
Jayshree, thank you for the invite, and very impressed, by the way, with the people that you have spoken with. You certainly have a respected community in my business, and I talk to a lot of people. I have probably 4,000 industry-specific contacts in LinkedIn, and use it, very selectively. But know some of those people, and very impressed with some of the things that you've put together in your organization.
Oh, thank you so much. I really appreciate that vote of confidence from you. And the goal of Risk Roundup series is that we want to report, we want to research, review, and report on the critical security risks that are emerging because of all this technology transformation and the advances that is happening, and the impact that is going to have on everyone, including individuals as well as entities across nations, is government, industries, organizations, and academia. And none of this is possible without the participation of thought leaders like you that are willing to contribute, participate so passionately, and advise and share their thoughts to our global viewers and listeners on what they feel that are the critical security risks. Because when we have the following from each and every nation, none of those nations, most of those nations, as you say, they are not able to go and listen to thought leaders like you at conferences. It's not possible, for every one of them to, be able to. So this format that we have developed is working out really well, and we are seeing a lot of, support from all across nations in understanding the security risks that are emerging. So having said that, let's start talking about this topic that we want to address today. So before we discuss post-quantum era, when we evaluate security breaches we see today, how would you describe the current state of IoT security across nations?
It's a free-for-all. And I'm glad you said across all nations. It's interesting. I submitted some comments to the last NIST IoT security draft. And what's interesting is they are working directly with the ISO. They have to. The world's changed. IoT is global. It's like it used to be just phones you used to bring overseas. Now you have to bring IoT overseas, and there's billions of them. So there is no national IoT. It is an international thing that we're all going to have to work together on. That's the only way it will work. These are smart cities. These are smart transportations. It's critical infrastructure. There's a lot of different things that it's going to use. And although I see ecosystems to be very important, people have to look at these things and machines. But it has to be something that can go across and migrate across any type of technology that there is. So IoT is pushing us into a different direction, and that's what I like about it, and that's what I fear about it also.
Yes, very true. It is pushing us, no doubt about it. So when we look at all the current security solutions that are available, from encryption to so many different solutions that are out there. How effective are they? Because when we are talking about IoT security, we have to evaluate whether it's data in rest or data in motion. What are we securing? Are we securing the hardware? Are we securing the operating system? What are we securing, and how are we securing? And would any of these solutions that we have currently stand the even averagely powered quantum computer if it emerges today?
IoT is interesting because it pushed security into a whole different level. It says, okay, first of all, I'm very small. I have no space for a lot of software. I have low battery, so if you're going to use too much of me, my battery's going to go out. I'm not going to work anymore. So even in encryption, it really took a completely different look. And current encryption technologies really can't even work in it because they're too large. It's too large of a file size. And at the same time, IoT is very important. We don't think it's that important because it's very small. It's very inexpensive. But it's as important as your eyes and ears and your touch, because that's really what IoT is. It senses what's out there in the physical world. That's the big difference in security. We're not talking about losing money, losing databases. We're talking about machines turning on and off. So it's something that surprisingly came out without security. That was for cost benefit reasons. It's nothing new. We've done this before. But what's happening now is people are realizing that, hey, this is all part of the risk management. You might be able to gain some things by knowing that your motor is going to go out in a few days. There's so many things. I always say, hey, I'm getting older. I might want a pacemaker. It's an IoT. Am I going to say, oh, no, if you can't secure it, I don't want that? It's a trade-off. But it's also just extremely important to look at now. Because as we migrate later on into quantum, and quantum is going to give us so much different intellectual property, we're not going to be able to even understand most of the stuff. But IoT is that very, very important step that has to be secured. I'm in the critical infrastructure business, so I really have a big bias. You can't buy an electric motor that doesn't have 5 IoTs in it right now. It's really, really difficult. You're looking at business trade-offs, but you got to look at security trade-offs too, and it can be done. So that's what we have to do. We just need to move forward.
Yes, very true. We have to look forward. At the same time, you made a very interesting point about this, nature of the things, the IoT devices that we are using. They're small. Their battery power, that is also a challenge. And also, we don't have much standards across, the IoT ecosystem, in the sense that, anybody can, make those IoT devices, and most of them, lot of them or most of them, they probably don't have the capability for encryption, and this encryption strength is directly tied to key size. And as the key size increases, we will need different kind of resources to perform the computation. So if we don't have the proper encryption, embedded into those IoT devices, what do you see the future of the encryption, if we talk specifically about encryption, as we go closer to the quantum era?
Well, there's two things with encryption that I see. One is throw away the key. You can't manage billions of IoTs. You just can't do it. Banks barely manage keys. So you have to look at something different than what we have done in the past. The keys have served us well. Encryption algorithms have served us well. They're also 50 years old. It's kind of time to move on to other things. So what happened with IoT, it sort of forced the issue. If you have a static encryption, you basically have something that can be defined and can be seen with higher computing power. So you have a two-edged sword with IoT. One is you have to make it very small. The other is quantum computing will break all existing encryption. Again, if you have static encryption, you have a beginning and end. I don't care how complicated the formula is. The computing power quantum is going to be so great, it will be able to basically break all encryption. Then you have the problem saying, well, how do you make it small so that it can actually fit in an IoT? And I've had the ability, my not-for-profit is Project Safety, and I've had the ability through the years of looking at some, real brilliant designs, brilliant people. Very hard, of course, to get through standards groups and all those things, those hoops that we got to jump through. But there are solutions and working solutions. These are not just proof of concept. These are solutions that are actually out and working. And interestingly enough, again, I never saw NIST, first of all, open up to the public and saying, we know we're in trouble. Okay? What do you got? And I respect the organization for that. And the comments that came were amazing. I mean, from the Intels of the world, little guys like me, there were lots of comments knowing that IoT is different. And again, this is what's forcing different ideas onto, okay, how do we now encrypt this? And how can we do it in a very small file size? Some of these things can be done, and some of the people I'm working with can.
Yes, very true. I mean, some of these things can be done. I mean, we need a lot of brain power. We need new ideas, new way of new imagination in how we can, change these complex challenges coming our way, because these are very complex challenges, and the security of the internet. People, I mean, it is said that it's based on a simple mathematical premise where we factor a large semi-prime number into its two prime numbers, and it's very complex mathematical stuff which I don't want to get into detail right now. But why should we be paying attention to quantum computing and think about the post quantum cryptography? If we want to secure the IoT devices, do they all need to go through the open internet? Because that's where the complex challenges emerge. Can we create an ecosystem of IoT devices that is local and that doesn't have to be part of the open internet?
Communications is my background, and from the beginnings of the internet to private line security to intranets, a lot of different things. There are ways to carve out intranets. There are ways to carve out private networks. But when you get down to it, you can still get in. A lot of people will always kind of point as the internet is where the problem is. It's really not. It's the software. It's the all the way to that end user, all the way to that small tiny device. We did pretty good job with securing networks and did a lousy job with securing software. And that's really where some of the issues are. So there's two things that really need to be done, intrusion prevention and intrusion detection. I think a lot of people have done a good job in the detection business. But when I talk to customers, they don't hear about, if they got hacked or not. They didn't want to be hacked. What we really have to do is start to look at intrusion prevention. And that's going to require us to focus on cyber defense, not cyber security or not cyber offense. We have to start looking at defense. And again, this is where I see IoT as being a very good model of saying, okay, how can we really do this? So to do it, you need to do two things, basically. You need to find how you can encrypt something that's very small. I fortunately worked with a brilliant scientist, ex-NASA scientist, and he made something so small, and I asked him, how did you possibly do it with so many few kilobits? And his answer was, well, I had a chip up there once, and he gave me 2 kilobits, so the mother of invention.
Yes, very true.
So he had a brilliant idea and said, look, rather than encode and decode, why don't I just trick you on the other end, and I'm going to scramble. So I'm going to be a little I'm going to flip this stuff around so quick, and I'm going to do it all the way down to the processor level. Now that's where we have to be. That's what IoT did, is it pushed us to the processor.
Yes.
So that's not only the hardware, but it's the software, it's the bus action, it's that little tiny event that could be extremely important. It could turn on a compressor, it could turn on a power system, it could turn off a power system. So we have to now, and we have to secure deep. This deep learning. I do appreciate artificial intelligence, but artificial intelligence is also software. And DARPA 2 years ago had a very interesting DARPA challenge that they do at, I think it's DEF CON. And they said, okay, so we know that artificial intelligence can help us in cybersecurity. It can define some breaches. But what could it do to the hacker? So the DARPA challenge was $1 million. They put out pretty serious money in it. You basically they used AI to hack AI. So
that's going to be a battle of AIs. That seems very interesting, Larry.
yeah, and that's really, again, our weakness is our software. We got to understand that. So we got to look at what our software is doing. We have to look what our entire processes are doing. We need to create baselines so that we know what's right and what's wrong. Now that's difficult. It's a lot of stuff is going on. We have connected things so rapidly though that operating systems today are, a person touches a button and I say, well, what did you turn on? And they say, I have no idea. I mean, that's really where we're at. We have machines that are not encrypted. We have machines and machines that are not even seen. Okay, you don't know what one machine is doing to another machine. So again, that's what IoT is doing. It's pushing us to a point of saying, okay, how do I do this down to this tiny little device with a very low overhead? When you do low overhead, by the way, it's very fast. We're talking about milliseconds. And machines, I always say machines think in milliseconds, and I don't. And that's what people need to understand. Those machines are working real quick.
Yes.
So it can be done. There's ways to encrypt, and there's also ways to assure and audit that that device is doing what it's supposed to be doing.
Yes, very true. And you brought up very good points about that. This, if we want to secure, if we want the security in right way, then we do need to make sure that each and every device that we have into our IoT ecosystem, we have, there is an accountability for it, that we have some standards and we know how to, that all those standards are enforced, and that each and every device that we do need to make sure that they, IoT owners, that those device owners, they are accountable and they have proper processes and framework by which they can enforce the security, and proper tools, resources that they need that to enforce the security. Because with the if the world, because everything is connected, if some devices are vulnerable, if the security is not enforced on them, then all devices become vulnerable, because that security is going to be compromised. So there are, we do need to, well, we are working towards right now to enforce the security risk management framework. The one I see is that not we don't have a very effective way of managing those security risks, and when everything is connected. But that is a topic of another discussion, and we have addressed that need for effective security risk management framework on several risk roundup episodes. So we won't go into that. But if you talk about the quantum computers, how far are quantum computers? If they arrive today, do you see any of us being prepared for the security vulnerability?
Well, quantum is unique in a way that it's going to basically touch something, what it is, and it will do that very securely. There, you can't crack the string of information of qubits. Very hard to enter. We have to still get to that point of actually knowing what we have. But quantum computing is going to really push us to a whole different level. In IoT right now, it's really the same thing, because IoT is really a tiny sensor in most cases. It's touching something and it's saying, okay, this is what's happening. Now we have to make sure that, yes, that's what did happen. That's the information you're supposed to give me. You need to validate that information, and you need to secure that information. If you don't, it can happen, unfortunately, in the physical world is what has already happened. You can use IoT for a lot of different things. Denial of service was one of the most recognizable. It's still in the IP world, and it was actually a pretty good idea, hacker, but they think fast. Said, okay, if all those IPs are out there in IoT, why don't we just suck all those out and knock it out? It's just a lot easier.
Yes.
And you brought up standards and framework, and I understand. I work with the groups. Standards and framework is important. I have slight differences in cybersecurity because a hacker did something, and I have to wait for standards and for these type of rules. And I'm a believer in scope of work and getting it out there, running it, and not, and having people look at it. I'm in favor of shutting doors and shutting up. But we have to change our cyber defense mentality because the hackers are doing things fast, and we're analyzing. And sometimes I hate to say it in standards groups. Sometimes we're giving them the roadmap of hacking. I mean, 1,000 eyes on something. Again, I've been in the groups. I would have never thought of a certain thing that somebody else thought of. That's just the advantage of standards. But we're in a situation that we have to react and we have to work very quickly in cybersecurity. So we have to have a different model that I think even Department of Homeland Security, NIST, DARPA does this in a lot of ways, but they should be supporting scopes of work, not some standards group.
Yes.
Let's not wait for a standards group to come out. Let's support society, and there are many ways to test it, and let's just test that good idea. Let's have it in our back pocket and ready to go if we need to have it. And I think we have to start thinking that way in security because it's that quick.
Yes. Yes, very true. That's a good point. Now, if we talk about this quantum cryptography and the quantum key distribution, the no cloning theorem, it seems that it's becoming one of the fundamental principles, and it's going to be probably at the center of our, next generation security defenses. So, while products based on quantum key distribution already are being used by some, I think most of the banks and some other entities also. I think governments are also using it, some governments, not all governments. It seems that they are not being used in a commercial sense by industries, many industries other than banking. So do you anticipate that this is going to change and that this quantum key distribution will have a broad commercial usage across NGIO, that means nations, government, industries, organizations, and academia?
Yes, I think a couple things have to happen when again, IoT has forced us to think so many different ways. So you don't have millions, you have billions. And when you have billions of IoTs, they're almost impossible to manage. It's like the nerve endings. Every nerve endings in your body, and you have to manage that, and you have to know exactly which one it is. It's just very, very large. So with that, key encryption is just too difficult to manage. We didn't even talk about authentication yet, too, and I might jump into that. Authentication has to change. Authentication is extremely important. That's really the key to everything. You got to know what did what, and you have to follow that track. But people do certain things, and actually the largest breach in security and cybersecurity still is. The inside human error is still the largest breach we have. Well, if humans are going to make a lot of mistakes, we should have a different authentication machine that really doesn't make and does things very quickly. But we're going to have to even kind of authenticate a little bit differently. To have machine-to-machine authentication maybe be different than human authentication. And that has to be all the way to the, think about, I mean, it's kind of horrifying in a way in security. 1 second, please. I just saw something about my battery. Okay. Um, one of the difficulties that we IoT is there's a lot of things going on. Well, with all those IoTs out there, how do I know that I'm turning my garage door up and not my neighbor's? That was the problem years ago. How do I know that I'm turning my power off and not theirs? You have to authenticate very specifically to what you are using, and that is key critical. Now, authentication currently um, is done again through keys or through a way of managing that's too difficult. You just can't do it. So you have the same problem with encryption as you do with authentication.
Yeah, yes, you made an excellent point about authentication, and I think that's where we are facing a lot of challenges as far as security. If we focus on security, authentication is one of the key problems. And but when we talk about these quantum computers, at what stage the development is, I mean, it's a lot of people say that they are still in their infancy, but these developments happen in privacy. We won't know until it hits us that the quantum computers have arrived. So if that is the case, and a mature quantum computer hits us, let's say tomorrow, or day after tomorrow, or next month, uh, how quickly, I mean, how much time would we have to prepare ourselves to upgrade our infrastructure? And how would we upgrade the infrastructure if the quantum computers hit us with, if we don't have effective technologies or effective solutions available today that could be quickly used by entities across NGIOA to quickly upgrade their security infrastructure?
That's an interesting point because quantum touches something that just says this is what it is, but you're not telling me necessarily what to do with it, or I have to know what to do with it. So that's real important. It's going to be very specific. It's going to give us intellectual property. And we had quantum computing is really going to be pretty remarkable. But we have to be able to authenticate from beginning to end. And if we can't do that, that's when we start running into more and more issues. Um, we are today. There's we IoT, for instance. I work with a company. In the old days, we used to be able to go into a city and we say, "Well, I can see 20 different Wi-Fi connections." Well, now you go to an area and say, "Well, wait a second, I can see 3,000 IoT." So we have to start defining our ecosystem as what we should be using and what we shouldn't be using. We have to start eliminating other things we're getting into our ecosystem. So all of that is communication, and that again has to be done very quickly. It has to be done very accurately, and it has to have levels. There has to be a lot of levels involved in authentication now because we're putting a lot more levels in.
Yes. Yes, no, that is very true. Now, in addition to the authentication, it seems we will also need to increase the computational power for security. And what new procedures do you think are necessary, and what new procedures do you think are being developed for increasing the computational power that would need to support the IoT system through quantum computing?
That's a difficult one. And it's going to take, by the way, international thought. Quantum
Yes.
computing is as important as the atomic technology. It's huge. It's the intellectual property of everything. So it's going to have to be treated with respect. It's going to have to be something that's going to be understood and appreciated on a global basis. It's going to have to take collaboration by a lot of people all over the world because the responsibility of it is tremendous. I mean, think about not knowing something and then finding it out in a millisecond, and nobody else has this because you have a quantum computer and they don't. That's world changing. So it is something that we're going to have to really look at. And I think again, I think IoT and securing IoT is the first step into it. And that's why I think I'm focusing on it now, because with quantum just around the door, I think the learning process will be learned through IoT.
Yes, no, very true. Now, if you look at the governments, how are governments attempting to address the IoT security?
It's the public-private sector needs to sit in one room. I spoke at Oak Ridge National Labs, and that's the home of the Manhattan Project, where the secrets of the atomic bomb were kept. And the communication I had there, including myself, was some of the stuff we have to sit in the same room. That's public-private sector, and we have to shut up sometimes. And that's really the kind of world we're living in. Think about daily when you have quantum intellectual property coming up on an hourly basis. I mean, things that we've never thought of, never knew that was possible. That's how it's going to be. So I think there has to be a public and a private sector to work together, certainly in privacy, and a lot of things to be honest, because I get between them all the time. Intel agencies from the government standpoint, and some of the biggest corporations with funding and a lot of technology sitting at their doorstep. And it's interesting where I'm at, being in Tampa. We have CENTCOM here, and we had a very interesting group that spoke. And we had the Intel community, one of the larger venture capital people that was investing a lot in IoT. And believe it or not, it wasn't a yin and yang conversation. There was a lot of agreement that they all need to collaborate and they need to share and they need to discuss. These things are seriously important in the physical world. So it can affect all of
Absolutely.
us.
Absolutely, collaboration and cooperation is the key. The problems that are coming our way, and the solutions that would need to be developed and implemented would require collective intelligence and collective efforts. Without that, it's not going to be possible to solve some of the big complex problems, security problems coming our way. But if you talk about quantum computing and what would need to be upgraded when quantum computers hit us, and it becomes a common thing across nations. What specific things needs to be changed or replaced, like from hardware to software? What needs to be replaced for effective
I
security?
think rather than we have to interface. I come from the days from analog copper to fiber optics, and that's what we did. We migrated, from analog to optic light, and that's the same thing that we're going to have with all the software, all the hardware that's out, into quantum computing that will give you some additional capabilities, but it's a matter of finding ways for them to work together, which we're already doing in cybersecurity. Quantum is a pattern. It's not software. It doesn't link and unlink. That's why we're getting hacked right now. That's why you can't hack quantum. Interestingly enough, some of the ways that we're looking at today of actually making sure that a device is doing what it's supposed to do is looking at that device and making a pattern on it. Well, that pattern can actually be a way of quantum computing learning what that device is doing. So we are already seeing migration paths of quantum computing into our existing technologies. And you were talking about 20 years of stuff that has to integrate. I think quantum has its place. I think it's going to be remarkable. And again, I see IoT in the way I think, which might be different than other people, as being that stepping stone to quantum. Let me give you an example, by the way. Um, IoT is our senses, okay? Our eyes, our ears. That's what IoT does. It collects that. Interesting enough, and I go that far back, analog sensing devices were more accurate than digital. Digital kind of chopped it up. Uh, well, what's interesting with IoT is that it's sometimes just grabbing that information and can grab it in that same way of looking at it as a pattern. Well, if you have the pattern, you actually can more accurately define what is going on. So IoT and quantum are going to interface very easily.
Yes, yes, yes. No, that's a good point. Now, as we move forward, as we get closer to quantum computer era and probably then beyond, what do you see coming our way? What do you see that concerns you from the security perspective, not just about the post quantum era, but beyond that?
Centralization is something that we have to be concerned with. Some of the countries that are investing a lot in quantum computing is China and Russia. It's because they already have centralized societies. So for them, it's perfect because it's like, okay, we already have a centralized society. Look, you just touch my quantum and I run everything. It doesn't work that way with other nations. And I also think that quantum might give you everything, but it still takes that very mind creative person to actually understand what quantum gave you. So I think there'll be a win-win way around. I do think though that we have to be again respectful to a massive amount of intellectual property that we're going to gain through quantum. It's just going to be remarkable. And with that, I think we have a choice to isolate ourselves. I think countries are going to have to work together. It's just like, now we have a scientist that knows how to make atomic bomb times thousands because the quantum computer just taught him something that nobody else even thought of. So it's going to be a whole different era.
Yes, it is going to be very, very different. So, what would you like to tell our global viewers and listeners, especially those who are concerned about the post quantum computer era and all those young, brilliant minds across nations who are very passionate about making a difference, not only for their nation, but for the global community and the humanity and our coming tomorrow?
And I think the realization of the power of quantum is going to push us into that. I mean, we just have to understand how important that's going to be, to our future. That's going to put us on other planets. That's going to let us understand, our Earth better than we've ever understood it. So, that's something you work on, not separately, and that's really the future that I see. And I work with scientists all over the globe. So, scientists are scientists. They are national, but they're not. They're brilliant people that most times, and I say most times, want to do the right things. And those are the people that I work with and really proud to work with.
Yes, very, very true. Most of them want to do the right thing. It's just those very few or those exceptions that want to do wrong and harm the humanity or their nations or anyone that is their target. That is the cause of concern. So thank you so much, Larry, for participating in this roundup today. We appreciate your thoughtful insight on how to secure IoTs and the state of IoT security in a post-quantum computer era. And our global viewers and listeners would benefit tremendously from the understanding you provided on the state of encryption and its vulnerability and security. So even if a single individual or entity can understand the complex security challenge facing the IoTs in the post-quantum era and prepare or protect themselves based on the understanding they receive from this discussion we had today, this risk roundup dialogue has been of service, and we thank you for that.
I thank you for your organization. IoT is going to force us into a global world as quantum is. So, again, as I said before, we don't really have a choice, which maybe is a good thing. Thank you so much.
Thank you so much. So, security is a complex challenge, and Risk Roundup, a global initiative launched by Risk Group, is a security risk reporting for risk emerging from existing and emerging technologies, technology convergence, and transformation happening across cyberspace, geospace, and space. We at Risk Group believe that risk management, security, and peace, they walk together hand in hand. Though security is related to management of threats and peace to the management of conflict, Risk management is related to management of security vulnerabilities as well as management of conflict. And it is not possible to conceive any one of the three without the existence of the other two. All three concepts feed into each other. We believe that the security we build for ourselves is precarious and uncertain until it is secure for everyone across nations. Tradition becomes our security, so if we build a culture of managing risk effectively, it will lead us to security and security will lead us to peace. Let's manage the existing and emerging risks together. For more information on the risk roundups, to watch the risk roundup videos or hear the risk roundup audio podcast, please go to riskgroupllc.com and do not forget to subscribe and share. Until next time, I'm Jayashree, host of Risk Roundup, signing off. See you next time. Thank you.